and thank all of you for being here this evening. We sometimes say that the Shine Dome is the spiritual home of science in Australia, but of course our forebears tens of thousands of years before us occupied this land, the Ngunnawal people of the Wiradjuri nation. And I'd like to share with you a welcome for country that Auntie Nora gave us when we had a Future Earth Symposium here a few weeks ago. And I thought it was something that Auntie Nora would be happy for me to pass on to you. In her own language, she welcomed us to country and said that the footprints we have left on this land are footprints that we would like you to tread in. So I welcome you on that behalf. As we share our own knowledge, teaching, learning and research practices, we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. Distinguished guests, friends, colleagues, welcome to the Australian Academy of Science. And admitting new fellows, of course, is one of the greatest privileges that someone in my position can have, and it's something I look forward to every year. I've only done it once before, so it's still a novelty for me. And the new fellows, welcome to you especially. Of course, you're here tonight because we're recognising you for the most outstanding contributions that you've made. And my warmest congratulations to you on your election. It's probably the most formal part of the work that we do in the Academy is to welcome and induct new fellows. And we take this serious tradition very seriously because it's one that was established by the founding fellows of the Royal Society several centuries before, of course. We're only some 60 years old. Some 300 years ago, they also had a tradition established which they followed in the Royal Society. We're based very much on the traditions that they developed. And upon admission to the Academy, by signing the Academy's charter book, you subscribe to the following obligation. I hereby solemnly promise to promote, declare, and disseminate scientific knowledge and to serve the Academy according to the Charter and the bylaws. The Charter book was a gift from the Royal Society when our Academy was established. It was established by eminent Australians, as I said, some 60 years ago, or 1954, a little bit over that, and it's been signed by all fellows of this Academy, and your signatures will sit alongside those signatures of your predecessors. And if you haven't had a chance to look at the book, there'll be an opportunity after today's ceremony. And in order to get the process going, I'm going to introduce the Academy's Vice Presidents, and I'll ask them now to come forward. Professor Jagadish, Secretary for Physical Sciences, and Dr. T.J. Higgins, Secretary for Biological Sciences. And Jagadish and TJ are the people responsible for this week's events as in the way in which the officers run the events. Of course, we're backed up by a huge support staff led by Karen Holt and Kylie Walker and Mitch Piercy, but with many other names. Nearly everybody on the staff has had a hand in making this week's events what they will be. So the relevant secretaries, here comes Karen. And Karen, can we thank you now for all the work you've done. So the relevant secretary will read the fellow citation, and then that will be a short statement of your work. And at the conclusion of that citation, I'll invite you to sign the charter book. In fact, it's probably quite good to be poised and ready to sign as soon as the citation's been read. Then we shall shake hands and have a photograph and move on to the next person. So I'm going to hand over. The first person is on the physical sciences side of the spectrum, and so will be introduced by Professor Jagadish.
Yes, please. Thank you, Mr. President. Dr. Ian Allison. Ian Allison is a glaciologist who has greatly advanced our understanding of the role of Antarctica and sea ice in climate variations. He pioneered the study of Antarctic sea ice with innovative and challenging year-round field campaigns which documented for the first time the seasonal variation in growth, redistribution, and decay of sea ice through its interactions with the atmosphere and underlying water column. He has also shown the importance of melt and refreezing beneath ice shelves to mass loss from the ice sheet and vulnerability to ocean change. He has been an outstanding leader of the Australian Antarctic Program and international polar research collaboration over many decades, including co-chairing the Peak Committee responsible for the 2007-2008 International Polar Year.
I'm getting wired up.
I welcome you as a Fellow of the Academy of Science.
Professor David Bellwood. David Bellwood is a leading expert on the evolution and ecology of reef fishes. The central theme of his research is to understand the functional role that fishes play on coral reefs and how reefs have changed through evolutionary time. His research themes include ecology, functional morphology, molecular phylogenetics, and paleontology. At larger scales, he has made major contributions to our understanding of biogeography and the conservation of coral reefs, particularly the origin and maintenance of biodiversity hotspots, reef resilience, and the relationship between biodiversity and ecosystem function.
I welcome you as a Fellow of the Australian Academy of Science.
Thank you very much.
Take a seat. Just a bit closer, David.
Professor Benjamin Eggleton. Ben Eggleton is a leader in integrated nanophotonics and nonlinear optical physics and has made seminal contributions to the fields of optics, photonics, and optical communications technology. He has made significant advances in nonlinear optics, waveguides, soliton physics, and fundamentals and applications of slow light. He has made important contributions to optical communications technology with applications to ultra-fast and ultra-broadband and energy-efficient information signal processing devices that are chip-based. He established and shaped the research directions of the highly successful Center of Excellence, QDOS, and is working on creating a revolutionary photonic chip. He received the 2011 Eureka Prize for Leadership in Science.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations. That's great. Just a bit closer.
Professor Jeff Fincher.
Thank you.
Jeff Fincher has made a distinguished contribution to cereal chemistry and the grains industry through his work on the structure, biosynthesis, and digestion of plant cell walls. Plant cell walls are the most abundant source of renewable energy on the planet. They play a major role in human and animal nutrition and as sources of biofuels and biopolymers. His work has impacted on all these applications. He discovered many of the enzymes involved in the synthesis and degradation of cell wall polysaccharides of barley, particularly the 1314 beta-glucans that have a key role in the brewing industry and human nutrition.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations. Yeah, take a seat. Just a little bit closer so we can shake hands.
Professor Simon Foote. Simon Foote has contributed significantly to many different scientific disciplines. He was the first to purify the renin protein. He identified one of 2 chloroquine resistance genes in Plasmodium falciparum and was key in identifying the mechanisms of resistance to 2 other anti-malarials. He produced the first physical map of a human chromosome and was instrumental in the subsequent map of the human genome that was crucial for the sequencing of the human genome. He has mapped the genetic loci for many diseases and has found a new function for the platelet as a hunter-killer cell against malaria.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations.
Professor Maria Forsyth. Maria Forsyth is a world leader in the development of advanced materials for application in a range of energy and infrastructure technologies. Her group discovered a large new family of organic ionic plastic materials that are needed in advanced energy storage technologies, and she has also developed significant understanding of the phenomena of charge transport at metal electrolyte interfaces and within other novel electrolyte materials. This has provided a basis for the design of new materials for fuel cells, battery designs, and corrosion prevention technologies. Her achievements have been recognized nationally and internationally through a number of awards and leadership roles.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations. Just a little bit closer and look at the camera.
Dr. John Kierkegaard. John Kierkegaard is an outstanding agricultural scientist who has made major contributions towards improving agricultural productivity both nationally and internationally. He is highly regarded for his ability to invent novel crop management packages based on penetrating science and to integrate them into existing farming systems so that they are rapidly adopted. He played a key role in the successful adoption of conservation farming systems, that is, farming without ploughing the soil. He identified and then overcame the biological mechanisms causing poor yield of crops in these practices and greatly increased the effectiveness with which crops use water and nutrients.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations. A little bit closer. Look at it.
Professor Jeffrey Lindeman. Jeff Lindeman and his team identified the stem and progenitor cells that generate all ductal tissue in the breast in both mice and humans. His laboratory was the first to identify the culprit progenitor cell responsible for breast cancer in BRCA1 mutation carriers. Discoveries from his group have provided a new framework for studying the molecular and cellular events that lead to breast cancer, with direct implications for the treatment and prevention of breast cancer. He has translated his group's fundamental research findings into novel, early-phase clinical trials.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations. Thank you.
Professor Alexander McBratney. Alex McBratney is a world-leading soil scientist who conceived and developed pedometrics, digital soil mapping, and soil security, radically strengthening the knowledge base of soil science. He established new theory and empirical models of soil variation in landscapes and developed their applications, for example, in precision agriculture. His contributions have revolutionized the availability of soil information and led to improved agricultural practices with reduced environmental impacts and enhanced security of the world's soil.
I welcome you as a Fellow of the Australian Academy of Science.
Thank you, Mr. President.
Congratulations. We'll just show getting a bit closer.
Thank you.
Thanks, Sally.
Professor Patrick McGorry. Patrick McGorry's work has created new concepts for psychotic disorders and a new clinical and research focus on youth mental health. His work commenced with the development of a novel clinical service, Early Psychosis Prevention and Intervention Centre, that focused on the early phase of illness. This approach has been replicated worldwide and recently expanded to include other psychiatric illnesses. The concept of youth mental health has led to national mental health reform, including Headspace, a model that has also been replicated internationally. His work has led to earlier diagnosis, better treatment, and outcomes for young people with mental illness.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations. It's a pleasure here. Shake hands. Yeah, look at the camera.
Professor Neville Nichols. Neville Nichols is the world's preeminent expert on the nature, causes, predictability, and impacts of interannual climate variability in Australia and its region. His research is the basis for operational prediction of climate variations and their impacts, including droughts, crop yields, bushfire, and tropical cyclone activity, and human health impacts in Australia and elsewhere. He initiated and led the development of high-quality historical climate databases for Australia and their use in understanding the causes of climate variations and change, and led national and international assessments of observed changes in climate focused on climate and weather extremes.
I welcome you as a Fellow of the Australian Academy of Science.
Thank you very much.
Look at the camera. Thank you. Take one.
Professor Stephen Nutt. Stephen Nutt has devoted his scientific career to investigating the cell fate determination process, and particularly how a select group of transcription factors act as the master regulators of hematopoietic lineage commitment and cellular differentiation. Professor Nutt has made some of the most important findings in this field, including defining the roles of PAX5 and BLIMP1 in B-cell and plasma cell commitment, respectively. These studies had a major impact on both our theoretical understanding of cellular decision-making processes and in deciphering what goes awry in diseases such as leukemia and autoimmunity.
I welcome you as a Fellow of the Australian Academy of Science.
Thank you.
Look at the camera.
Professor Helena Rubinstein Dunlop. Helena Rubinstein Dunlop is recognized internationally for her achievements in laser physics, linear and nonlinear high-resolution spectroscopy, laser micromanipulation, atom cooling and trapping, and nano-optics. She is one of the originators of laser-enhanced ionization spectroscopy and is a pioneer of laser micromanipulation and transfer of angular momentum of light and all optical drive micromechanics. She initiated the experimental programs in laser micromanipulation and atom optics at the University of Queensland that culminated in the demonstration of dynamical tunneling in a Bose-Einstein condensate BEC in a modulated standing wave. She led the team that observed dynamical tunneling in quantum chaotic systems.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations. Look at the camera.
Professor Susan Scott.
Thanks.
Susan Scott has made groundbreaking discoveries in the fields of general relativity and gravitational wave science. Her theoretical work includes advancing our understanding of both singularities and the global structure of space-time. Professor Scott has also been a pioneer in the analysis of astrophysical signatures in gravitational wave experiments. She has been part of the gravitational wave team which has discovered the most recent discovery of the gravitational waves.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations.
Thank you very much.
I just need to get a little bit closer. Look at the camera. Thanks.
Dr. Daniela Stock. Daniela Stock is a renowned structural biologist best known for her work on rotary atapses. She redefined bioenergetics in the late 1990s by solving the X-ray structure of the F1C10 complex of yeast mitochondrial ATP synthase, which provided the first view of a biological rotary motor and introduced the concept of symmetric mismatch and non-integral proton ATP ratios in the field. Since then, she has combined the diverse complementary techniques of electron microscopy, domain antibody technology, mass spectrometry, and molecular dynamics to provide a dynamic and almost complete molecular picture of rotary ATPases, leading to major new insights into biological energy conversion.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations. Don't take a look. Just get a bit closer and face it. Look at the camera.
Professor Fedor Sukachev. Fedor Sukachev is a world leader in finding novel analytic approaches to complicated interdisciplinary problems. His research covers the area of mathematics inspired by quantum mechanics, where commuting variables are replaced by non-commuting ones. He is an internationally recognized expert in three related but distinct areas: non-commutative analysis, non-commutative geometry, and non-commutative probability.
I welcome you as a Fellow of the Australian Academy of Science.
Thank you.
Congratulations. Just get a bit closer, look at the camera. Well done.
Professor Toby Walsh. Toby Walsh has made important scientific contributions in three closely related areas: artificial intelligence, constraint programming, and computational social choice. These contributions have strongly influenced both the theory and practice of how optimization problems are solved in industry. He has been a pioneer in theoretical artificial intelligence, building on ideas from fields including statistical physics, economics, and game theory to study many complex and challenging optimization problems such as scheduling and vehicle routing. His algorithms are included in the leading open source and commercial toolkits that are used to solve such problems in industry.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations.
Professor Naomi Ray. Naomi Ray is a leading complex trait statistical geneticist. She has significantly contributed to quantitative genetic and evolutionary selection theory with applications in agriculture and medicine. Her theoretical work on the prediction of rates of inbreeding in populations undergoing selection led to changes in agricultural selection programs worldwide in balancing genetic improvement with levels of inbreeding. She has developed innovative quantitative genetic methods for the estimation of genetic parameters from genetic epidemiology studies and methods for genetic risk prediction. She has applied these to psychiatric disorders, thereby contributing to the elucidation of the genetic basis of common, distressing, complex diseases.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations.
Sir Philip Cohen. Philip Cohen is one of the world's most eminent biological scientists in the area of signal transduction. Cohen identified a family of calcium, calmodulin-dependent protein kinases and phosphatases, including calcineurin, which was later shown to be the target of the immunosuppressive drug cyclosporin. Cohen identified components of multiple signaling pathways, and through the The establishment of the Division of Signal Transduction Therapy has had a profound influence on translational research and pharmaceutical drug development in this field. Over more than 30 years, Cohen has strongly influenced Australian biochemistry through his multiple visits, lectures, hosting sabbatical visitors, postgraduate training, and public lectures.
I welcome you as a Fellow of the Australian Academy of Science. Congratulations.
Thank you very much.
We'll just get another one. Yeah.
So Philip Cohen and Professor Matthias Hentz are admitted as corresponding members of the Academy. I just wanted to be aware of that. And Professor Matthias Hentz. Matthias Hentz is a world-leading biomedical researcher and early pioneer of RNA research. His contributions to translational control, including IRE regulation of ferritin, mRNAs, are now enshrined in all leading textbooks of biochemistry and molecular cell biology. His recent work in collaboration with Australian scientists has led to the discovery of hundreds of new RNA-binding proteins involved in gene regulation. These discoveries foreshadow a new phase in our understanding of genome functions and metabolism, with numerous biological processes affected by genomically transcribed RNAs that control the functions of existing proteins. In 2013, Hentz was appointed director of the European Molecular Biology Laboratory, one of the premier biology research centers in the world, and an official strategic partner of Australian science. Australia was the first EMBL associate member state, and the laboratories provide important training opportunities for Australian scientists. Hentz has received numerous prestigious research awards, including Germany's highest research honor, the Gottfried Wilhelm Leibniz Prize in 2000, and the Fedor Lenin Medal and Lecture in 2015.
I welcome you as a Fellow of the Australian Academy of Science, and as advised in the corresponding member class.
Thank you very much.
Herzliche gratuliere.
Dankeschön.
Bitte.
Distinguished Fellows of the Australian Academy of Science, it's my very great pleasure now formally to welcome you as members of the Fellowship. Warmest congratulations to all of you. We look forward to hearing your talks tomorrow, which is the pinnacle of scientific stimulation in this week, and everyone looks forward to it. We all learn something new. And before we move to a celebratory reception, I would like just to take a few moments to tell you a little bit about the Academy, to introduce those executive committee members and council members who are here, and I'll mention a little bit about the building as well. This is the first day of science at the Shine Dome for 2016, and it's an annual event where we celebrate not only the excellence of the science, but also the experience with you of your fellowship. We also take the opportunity to make and we've announced, but actually to complete our most prestigious awards. And finally, on the last day, we have a symposium called Human Plus, which will explore the many great advances in bionics, photonics, printable organs, and other sciences of human enhancement. Every year since 1954, the Fellowship of the Academy has gathered here for an annual meeting. From the original fellowship of just 23, the founding fellows, we now have this year a total of 500 fellows. We've elected 23 fellows this year. One of them is a special election fellow and 2 corresponding members. The special fellow is Dr. Alan Finkel, our chief scientist, who will be here tomorrow to present a talk and to sign the charter book. Our early fellows, of course, were very largely of Anglo-Saxon origin, but now we represent a greater range of diversity, I hope moving towards representing, but with opportunities to improve the diversity in Australia itself. The age range of our fellows is 42 to 100, but I'm ashamed to say that the age of election is going up. And that's a challenge to all of us to try and bring it down a bit and still have the very best scientists, of course. Now, when you signed the Charter Book, of course, you joined luminaries such as Sir Mark Oliphant, the founding president, Sir Douglas Mawson, although it was mentioned to me by one of the new fellows tonight, I think Mawson's name appears before Oliphant's, Professor Nancy Millis, Professor Frank Fenner, and Sir David Attenborough, just to name a few. We're also proud to have Fields medalist Terry Tao and 6 Nobel Prize winners, including our most recent, Brian Schmidt, sitting up there, a member of our council. After this, we shall move into the Jaeger Room, which was named after the Professor of Geophysics, Professor John Conrad Jaeger, who was at the ANU. And like many of the other founding fellows, Professor Jaeger worked tirelessly to develop and advocate activities for the Academy. And this brings me to 2 very important points. The first one is the Academy is the fellows. We're supported by our building and by our secretariat, and we are the Academy. And the other little bit I want to slip in is that anecdotally, when I was admitted as a fellowship to a Cambridge college, I had to bow before the head of the college, the master, and swear that I would obey the master in the discharge of his statutable duties. So I hope you get the message. We're unique in Australia, and no other organisation quite brings together this group of outstanding scientists in the way that we do. We're here to promote scientific excellence. That's only a vehicle to champion the causes that we can support, fostering international scientific relations, increasing public awareness of science and technology, and engagement with the community at large. Our fellows serve on 22 national committees. These committees represent the main scientific disciplines in the nation, and their job is to set the roadmap for the discipline, to provide opportunities for international engagement, and to give advice in the Academy on policy documents and various public notices that we issue, policy documents, and also statements of policy. They also meet with the political leaders, and I'll have a bit more to say about what we've been doing leading up to the election. And they participate in our educational program and in our program called NOVA, Science for Curious Minds, which is a very successful website-based program. This year's been very busy and I think successful. Our work's established a new national program in gender equity, Science in Australia Gender Equity, which is to roll out the Athena Swan Charter here in Australia in a pilot program in partnership with the Academy of Technology and Engineering. And I'll have a bit more to say about that in my address on Wednesday morning. We've also established a new mathematics school education program in collaboration with the Australian Association of Mathematics Teachers. And as I mentioned already, we've created NOVA, a public science explainer website. We've informed national and international debates on research funding, climate science, brain research strategy, and more. We've provided scientific advice to parliamentary inquiries, educated young Australians at both primary and secondary level, and improved public understanding and engagement in science. And fellows will have a chance to talk about that informally with members of council and the executive committee who are here tonight, and to hear more formally about it on Wednesday and in our annual general meeting. And these contributions have influence because of the expertise of the fellowship. And we help Academy officers and staff to make timely but carefully considered expert reports and submissions on the issues of significance to the nation, and to ensure that our educational material is scientifically accurate and up to date. And you, as newest fellows, will be very welcome to contribute to all those activities, and I'm sure you'll be amongst the most enthusiastic. Please do let us know where you would like to help and work, and do be proud of your fellowship, and in the appropriate circumstances, use the letters, the post-nominals, FAA at appropriate times. The election process, which will be starting again when we have nominations at the end of July, is a long and exacting process, and it's one which is now focusing not only on excellence but also on diversity, all sorts of diversity. And it's involved your nominators, it's involved fellows on sectional committees, it's involved referees. And I'd like to acknowledge the very hard work internally of the fellows and the staff of the Academy in reaching the stage which has delivered you as elected fellows. Before we introduce the members of Executive Committee who are here and the council members, I just want to mention a huge gap in my own knowledge, which I've filled slowly this year, when we had the Minister for Science, the Assistant Minister for Science, Karen Andrews, on a tour of the Shine Dome. And she pointed to the foundation stone and said, "Where did that come from?" I didn't have a clue. So let me tell you now where it comes from, because I had a look at the plaque again. It's a pillar from a telescope which was erected originally in Australia, a 48-inch reflecting telescope, the biggest at the time, eventually was relocated to Mount Stromlo. The design of the dome is illustrated in the competitions which were entered by the various architects in the Jaeger room. So have a look at the designs. As someone said to me this evening, one of them looks like the Opera House. But there are some grand designs there. There were wells and fountains out on either side of the two X's, on the left and right of me as I'm facing you. And those seats you're sitting in were handcrafted by someone here in the ACT, and they were designed to represent the back of a car seat of the 50s. Does it feel like that to you? Are you feeling comfortably? Some people say it's designed to help you sleep during the lectures, but I do warn you that the challenge is to get out. So give yourself plenty of musculoskeletal extension before you try and get out. So now I'd like to pass on the introduction to the members of council. As I mentioned here, we have the vice presidents, Professor Jagadish and Dr. T.J. Higgins, who are the respectively Physical Sciences Secretary and Biological Sciences Secretary. And would you like to join us? The Foreign Secretary, Professor Cheryl Prager, who's the first one to stand, and the Secretary whose title always fools me, but Outreach and Education is pretty close, and Public Awareness, Professor Pauline Laudigas, and Professor Jim Williams, who is a council member, and I'll introduce him first as a council member, but secondly as the successor in a few days to Professor Jagadish as Physical Sciences Secretary. And then we have at least one other council member I've seen, Professor David de Kretser, if you would like to join us. Now, is Professor O'Reilly here? Yes. No? Oh, Brian is here. I've announced Brian, so I really ought to introduce him to you. Thank you, Brian. Is Professor O'Reilly here? No. So these are our council members. Brian is about to finish his service on council, and Jim as well, as I mentioned. And at the beginning of the AGM, I'll introduce those incoming council members who are here as well. At this stage, we do not have the Executive Committee members, Professor Les Field, who is the Secretary for Science Policy, and the Treasurer, Dr. Oliver Mayo, here, but they will be joining us later in the week. I think Oliver will be here later tonight, and Les will be certainly here tomorrow night. And also I would like Dr. Sue Meek to join us, our Chief Executive. Sue, if you would come up, please. And I hope that will introduce you to some of the familiar faces you'll see around here in the Dr. Meek in the next few days. So each year, this gives us, we the fellows, have the chance to meet old friends and to make new ones. And tomorrow, we're looking forward very much to hearing about your science. But now, I invite you to relax to join us in the Jaeger room next door, where you can enjoy the fellowship and something to eat and something to drink and talk amongst each other. So thank you very much for a very good start to this week's events. Thank you.